equation. I use the same process to find the landing velocity as I did the initial velocity, initial takeoff velocity. So I found the point that this starts to curve down, the points curve down, the horse's shoulder is on the downward turn, and that's around 2.26 seconds. So I kind of highlighted that time there, and then frame by frame went down until the horse's hoof meets the ground and the points start to level off. So I went back one frame from this. So from there to there, and highlighted those times, and then did the same thing. Found the linear fit. Perfect. And that gives me the x velocity, x horizontal velocity from this time that the horse is landing. And again, I have to plug that into a cosine equation using angle, which I will show you how to do now. To find the landing angle, I pretty much did the same thing as I did to find the takeoff angle. So I draw my axis right where this leg is pretty straight, right there, right below that fetlock joint. And then I used the ruler as a reference and kind of drew a line from that point all the way down to the origin, and then took a screenshot and moved that over into my online protractor like I showed you earlier and found the angle there. Interestingly enough, with those angles of the descent, the initial angles of takeoff all kind of varied depending on how far away they were from the jump at takeoff. However, the landing angles all seem to be pretty similar. They're all between 47 and 49 degrees, regardless of the initial velocity, the takeoff distance, the takeoff angle. All the horses seem to come down at about the same angle. In order to get the takeoff velocity, I use the horizontal velocity, Vx, and use this equation. So I took the horizontal velocity and divided by the cosine of the jump angle in radians. And then I did that all for all the velocities of takeoff, and then I did that for all the velocities of landing. Because each jump was approached at a different initial velocity, I could not directly compare the velocities, the initial takeoff velocities to each of the trials. So in order to get some sort of standardized value, I decided to derive a ratio. And the ratio I derived was the initial velocity divided by the final velocity of the jump. So the idealistic, beautiful jump would be roughly a 1-to-1, meaning that if the horse starts at a 5 meters per second, at takeoff, the landing will also be 5 meters per second. Now, if the horse gets a really long distance, from my research, I noticed that generally if the horse gets a very long distance, the initial velocity will actually be slower and the final velocity will be a lot higher, in which case the velocity ratio would be much smaller. Likewise, if the horse gets a very short distance to the jump, because they have to clear a lot of vertical height very quickly, the initial takeoff velocity is a lot higher than the landing velocity, in which case the velocity ratio is much higher in itself. So the ideal location for your velocities, velocity ratio, is this 1-to-1, the sweet spot right here. And I did notice that there was a trend in that the higher velocities, the shorter jump distance, the higher velocity ratio, the shorter the jump distance. Likewise, the longer the jump distance, the smaller the velocity ratio. It can be concluded that the most effortless jumps are those where the initial velocity stays consistent throughout the whole jump and is therefore very similar to the landing velocity. If the horse is forced to respond to a challenging distance, either too far from the jump or too close to the jump, this is how ugly jumps are produced. Difficult distances lead to major changes in the horse's velocity in order to safely clear the jump. The takeaways of this are majorly important in the hunter and equitation competitions. It is also important to remember that the takeoff distance is related to the total jump length. So if there is a particularly wide jump approaching, it is better to take a bigger distance to the jump rather than jumping close to the base. Overall, this strategic physics analysis can help the rider understand the best way to jump their horse and win in the show ring.